Every year, millions of echocardiograms are taken to measure how well the heart is pumping. That one number, the ejection fraction, tells cardiologists whether your heart is healthy, failing, or somewhere in between. But measuring it accurately still depends heavily on expert human judgment. What if an AI could do this from just a handful of labeled examples? Most deep learning models for cardiac analysis are data hungry. They need thousands of annotated videos to work well. And annotating medical data is slow, expensive, and requires specialists. That's a smarter starting point. Vision language models like CLIP, which are already pre-trained on massive amounts of image text data. One prior work, echoclip, tried adapting CLIP to echocardiography. But here's the catch. CLIP was built for images, not videos. echoclip essentially picks a random frame, ignores time, and averages predictions. For cardiac signals, that's a fundamental mismatch. The heart is motion, systole, diastole, contraction, relaxation. The diagnostic signal lives in the temporal dynamics, not a single frozen frame. CardiacCLIP fixes this with two ideas. The first is multi-frame learning, or MFL. Instead of averaging all frames equally, MFL asks which frames actually matter. It learns to assign importance weights to each frame using an attention mechanism inspired by multiple instance learning, where you assume only a subset of instances in a bag carry the true signal. In a cardiac video, those critical instances are frames near maximum contraction and maximum relaxation. MFL finds them automatically. The second is EchoZoom. Standard CLIP encodes everything at a fixed resolution. But cardiac structures, the ventricles, the atria, are often small and spatially precise. EchoZoom processes the image at multiple scales simultaneously, splitting high-resolution frames into subregions and fusing those representations back together. No extra parameters, just richer spatial understanding. On top of this, LVEF prediction is treated as an ordinal regression problem. Coarse classification first, then fine-grained regression, because learning relative order before exact values is simply more stable with limited data. The few-shot framing is what makes this clinically meaningful. In a hospital with a different ultrasound machine, you might only have a handful of labeled scans. CardiacCLIP is designed for exactly that, adapting quickly, generalizing broadly, without needing to retrain from scratch on a massive dataset. It's a blueprint for how to bring powerful pre-trained vision language models into medical video analysis responsibly.